Hey folks, welcome to Chapter 5, Section 5, Writing Polynomial Functions from Zero. So in this video, I'm going to be doing exactly that. I'm going to give you the zeros, and we're going to write the function from that. The function doesn't have to be terribly complex or specific. It just needs to have a leading coefficient of 1 and have these zeros, and then see it says function of least degree. And then, yeah, technically rational coefficients, but don't worry so much about that. Least degree meaning you don't have to worry about getting the exact power right, because technically there is an infinite number of functions with these zeros. The simplest answer would look like this. F of x equals x plus 2, x minus 3, x minus 6. That's the simplest answer. So you have a leading coefficient of 1. Now you don't have to worry about putting a number out in front here. Now, how did I arrive at that answer? Well, in previous videos, I said that when you're solving a polynomial equation, anytime you have an x, you set it equal to 0. So if I set x plus 2 equal to 0, I'll get negative 2, because negative 2 plus 2 equals 0. Positive 3 plus minus 3 is 0. 6 minus 6 is 0. So in layman's terms, just flip the sign, okay? That's basically all you need to remember, because when you plug in one of these numbers, it'll make one of the parentheses go to 0, okay? And then keep in mind, everything can be justified checking the graph. The graph of this would have x-intercepts of negative 2, 3, and 6, all right? So if I were to just flip the signs again for a different example, I'm going to write f of x equals, can't be a function unless it says f of x equals, or unless it equals something. So write f of x equals or y equals, but f of x is preferred. And then it says minus 4, so I'm going to put plus 4. It says minus 2, so I'll put plus 2. It says 5, so I'm going to write minus 5. And that's actually just going to be my answer. So you can always check this by typing this into the graph and then seeing that the x-intercepts are at negative 4, negative 2, and 5. But yeah, that's pretty much all there is for these first two examples. So for this next section, it's going to be a very similar thing. I'm going to give you zeros, but they're going to be on the graph. And so if they're going to be on the graph, then that's going to determine, the degree, or the shape of the graph will determine the degree of the function. We're supposed to write it of least degree. So like if it's an even function, we'll think of degrees of 2 and 4. And then if it's an odd degree, I'll just stick with 3, maybe 5 if needed. But yeah, that's what I mean by least degree. So don't worry about trying to make an even equation with a degree of 12, or an odd equation with a degree of 9, something like that. So most of the time when it's even, it's 2 or 4, and when it's odd, it's 3, the majority of the time. Now, this example A, this is going to be a degree of 4. How do I know it's a degree of 4? Well, it makes a W. And you'll recall that degree 2 problems, aka quadratic problems, make a U. So if it makes a W, then it has to be the next highest degree, which is 4. Notice I skipped 3. Why did I skip 3? Because it's both going up, so it's going to be an even degree, and 3 is odd. So if this tail's going up and this tail's going up, then it's going to be an even function, okay? And because it made a W, I know it's going to be an even function with a power of 4. Though that's the smallest degree possible that'll make a W for a graph. The next thing I want to determine is this a positive graph or a negative graph? I see both ends are going up, so that tells me it's positive. If they were going down, that tells me it's negative, okay? So let me just erase this just so it doesn't confuse you, but let me make note of that down here. Okay, so knowing that it's even and positive, that's going to help me write my equation. So I have a 0 at negative 3. So that's just x plus 3. And then I have a 0 at positive 3, so I'm going to write x minus 3. But if you look at this graph, it'll just be a u with a 0 at -3 and +3. I need it to look like a W. So this is power of 2. I have 2 x's. If you count your x's, you know what your power is or your degree is. So this is 2 degree. I need it to be 4 degree to get a W. So if I make this squared, this now has 2 x's, and now this makes 3 x's. But that's an odd function. I need it to be an even function. So if I square this as well, that'll make this become a W, and it'll make a graph that looks like this one up there. So I had to square both of these because it was an even function that looked like a W. If it was an even function that looked like a U, I wouldn't need those powers of 2, okay? But because it looked like a W, I had to add in those powers of 2. So I have 2 x's here and 2 more x's there, and it's all multiplying together, so that means it's a degree of 4, okay? So for letter B, is this an odd function or an even function, and is it positive or negative? I know it's going to be an odd function because the tails are going in opposite directions, and I know it's positive because it starts low and ends high. Any positive graph will end up going up, like on the right side of the graph. So this one's going to be an odd positive. Okay, so I wrote down that it's odd positive, so that tells me it's going to have a minimum degree of 3, okay? So I'm going to write f of x equals, and I have a 0 at -3, so that's x plus 3. I have a 0 at 0, but I'll get to that in a second. And then I have a 0 at 2, so I'm going to write x minus 2. So ordinarily you just add or subtract the number that's there. But if you don't have a number, then you just write an x. 0, x plus 0 or x minus 0 just makes x. So anytime you just have a random x, just throw that out in front. Don't put it in the middle. But yeah, this makes an odd function because I have 1, 2, 3 x's multiplying together, so I have degree 3. And so that's odd. And then the leading coefficient is 1 and positive. There's no negative in front of it, so that's how you know it's positive. So yeah, this graph right here, or this equation right here, would make a graph that looks kind of like this with these 3 zeros. And that's all there is to say about that one. Just anytime it's going through 0, 0, it'll be like x plus 0 or x minus 0, but you don't have to write the plus or minus 0. You just have to write an x. So for part C, what kind of function is this? Well, both tails are going in the same direction, so that makes it an even function. And they're both going down, so that makes it a negative even function. So this looks kind of like an M. The first one we did looked like a W, so that gave us a power of 4. So if it looks like an M, we're going to have a negative out in front to make it negative. Oh, I wrote down positive even though I said negative. So let me change that. So I need to have a power of 4 again, just I need to make sure it's negative. So I have 3 zeros, so I'm going to write down all 3 of those. So I'm going to write down f of x equals, and I had this going through 0, 0, so I'm just going to throw an x out in front. And then minus 3, that's going to become plus 3. And then I have a 5, so that's going to be minus 5. So if you look at this, this is a degree of 3 because I have 1, 2, 3 x's. I need it to go up 1 more degree. I need it to be degree 4. So it's as simple as this. I'm just going to square this x. That's just going to make this have 2 x's, and then a third x, and a fourth x. Now, how did I know to square this x versus squaring something else? Well, you know, I can't really show you the graphing calculator at the same time I'm doing this, but just know that if you square this x, you'll get a graph that looks kind of like an M. If you put the square here, you get a graph that looks kind of like an M, but it looks way different. It looks kind of like that. And same thing if I put it by the x minus 5. So it just looks too different from this, and so I put the power of 2 there. But technically speaking, I could put the power of 2 here, and I'd have 1x here, 2 x's there, and 1x there, making 4 x's total. So I hope I'm not over-explaining it, I have 3 zeros, so that means I'm going to write down x 3 times. And one of these x's needs to be squared, so the simplest way of doing that is just putting the leading x and squaring it. That'll give me a degree of 4, because 2x is here times this, third x, fourth x, okay? Now, the only thing I need to add to this is a negative. That'll make this be a negative graph. It'll make it open down, okay? So any of these can be checked by graphing. You would graph your answer, and then you can do, if you're using the TI Inspire Menu 6.1 to verify that it's touching at the following zeros, and then just looking at the appearance of the graph, it should look something like this, okay? Or something like what's given to you, I should say. So yeah, there's that section right there. So here, the last group of examples I'm going to do deals with the irrational conjugates theorem, which states, let f be a polynomial function with rational coefficients and let a and b be rational numbers such that the square root of b is irrational. So that's like you're taking the square root of a prime number. But the important part is this. If a plus square root of b is 0, is a 0 of f, then a minus the square root of b is also a 0 of f. So I have these two examples here with only 2 zeros listed, 3, 2 plus square root 5. What I'm going to do is I'm going to add in a third 0, and it's going to say 2 minus the square root of 5, because that is what it is saying right here. See, if it says if a plus square root of b, then a minus square root of b is also 1. So this one says 6 minus square root of 7. I'm going to add in a third 0 that says 6 plus square root of 7. Okay? So that's just getting started. So let's finish problem A right now. My first 0 is a positive 3, so I'm going to flip the sign, and I'm going to write f of x equals x minus 3. My next 0 occurs at 2 plus the square root of 5. That's one number. I understand you're reading two numbers, but that is one number. You can type in 2 plus the square root of 5, and the calculator will tell you it's 4 something. So I'm going to write down x minus 2 plus the square root of 5 in its own parentheses, because, like I said, it's one number, so I'm minusing out that one number. If you didn't put parentheses, then you wouldn't end up distributing that negative, and you're getting different values, and it's just going to be wrong. And so I'm going to go x minus, and then I'm going to do 2 minus the square root of 5 for the last 0. And so what I need to do here is just simplify this. In other words, the first thing I can do is distribute that negative. So I have x minus 2 minus the square root of 5. And then I have x minus 2 plus the square root of 5. And I'm going to group these x minus 2's in their own parentheses, because just to highlight that it's happening twice. I have an x minus 2 twice. So if I'm going to simplify that further, I'm going to write x minus 2 squared. Okay? Because they're both multiplying if they're in parentheses. So yeah. So you can write it as x minus 2 squared. And then how can I simplify this? The negative square root 5 and the positive square root 5. That's going to end up just making a negative 5. Now, why is that? Well, if I multiply the square root of 5 times the square root of 5, that's like saying the square root of 5 squared. Well, squaring a square root cancels itself out, and you just get 5. But since one of them was positive and one of them was negative, then you get negative 5, okay? So, yeah, I have the same number here, just one's positive, one's negative, so the square roots cancel each other out, and I'm just left with negative 5. And then this x minus 3, don't forget about that. That gets carried down in each step, technically, so it's never going to change. So this right here is all I'm looking for the final answer. This is simplified enough. Although I do need to say this. This part, the x squared minus 2 minus 5, needs to be in its own parentheses, because we just simplified these two parentheses to make this. So if you were to expand everything out, and you didn't have this in its own parentheses, you'd get a slightly different value because you'd have to expand out x minus 2 squared and then minus 5 from that. Whereas if you didn't have the parentheses, you do PEMDAS, you do this, you'd expand this, then you'd multiply it by this, and then you'd add in minus 5. And so now you've changed the order of operations. So long story short, just put that second part in its own parentheses. You have like a double parentheses thing happening there. But this is the final answer, okay? So I'll do one more example like this, and, it looks a little confusing, but hopefully it'll make a little bit more sense. The first number is always going to be, plus or minus, whatever, the opposite sign of that. And then it's going to end up saying x minus this number squared, and then it'll say minus whatever this number is without the square root. That's what my answer will have, because that's what my answer had here. So that's just kind of like a pattern of this. So I'm going to write f of x equals x plus 4, because I was given a negative 4. And then I'm going to write x minus, and then I'm going to put 6 minus square root 7. And then I'm going to say x minus 6 plus the square root of 7. Okay, they're in their own parentheses because 6 minus square root of 7 is a single number when you type it into the calculator. So I'll distribute my negatives. And so I have x plus 4, that remains unchanged. And then I have x minus 6. And then I'm going to keep that group together. And then that's going to turn into plus square root 7. And then I have x minus 6 again. So that's why it's grouped together in its own parentheses. But now it says minus the square root of 7. And so I'm going to combine my x minus 6's to say x minus 6 squared. I'll bring down that x plus 4. And then the square root of 7 times the negative square root of 7 just makes a negative 7. And then I'm going to put this in its own parentheses right there and throw my f of x equals in front. And that'll be my final answer. All right? So, yeah, it's a little weird, but like I said, you'll flip the sign on this, x plus 4, and then I said this will say x minus 6 squared, and then it'll say minus 7, which is what it said. That's kind of the pattern of these. I don't know if that helps pointing that out, but that's how it goes. But other than that, thanks for watching. Like and subscribe. All right, goodbye.